Good morning, ma'am. Good afternoon. Good evening.
Good evening, children.
Good evening, ma'am.
Good evening.
On your video.
Good evening, ma'am.
Good evening. Arjun, you have logged in from two different devices. Log out from one device and turn on your video. Yes, all of you kindly turn on your videos. Yes, thank you, Devadarshini, Sindhu, Sanjay, Netra, Madhumita, Arjun, others. Arjun, log out from the other device. Yes, Rajit. Danya, Udanshri. Arjun, can you hear me? Please log out from one of the two devices. Okay, I think I've done now.
The device.
All right, children, put your mics on mute. This is where, we stopped in the last class. We understood how to solve using algebraic identities. These identities we are already familiar with. We have seen them in standard 8. Yes or no?
Yes, ma'am. Yes, ma'am.
Okay.
Yes, ma'am.
So have we completed all this, children?
Yes, ma'am. We have written it. Yes, but we didn't discuss, ma'am. Only the first question we have discussed.
Yes,
Oh,
ma'am.
we've done. Okay, we've done only the first one, is it? We are still to do the others?
Yes, ma'am. Yes, ma'am.
I think I'd asked you to take a screenshot of the answers and asked you to complete the same, right? No?
Yes, ma'am. Yes, ma'am.
Yeah.
Yes, ma'am.
Fine. All right, children. Now answer these questions. Tell me if the what I write on the screen is rational or irrational. Yeah. Is 5 by 7 rational or irrational?
Rational, ma'am.
Rational. Rational.
Yes,
Is
ma'am.
root 5 by okay. Root 5 by root 7.
Irrational, ma'am. Irrational, ma'am. Irrational.
Irrational. Why? It looks like integer by integer, no? Just a second, children. Just a second. Yes, children. So root 5 by root 7. Root 5 by root 7 is not, it may look like something upon something, but it's not integer by integer form. It is not integer by integer form because root 5 is not an integer. Root 5 is not an integer. See the integers, see the collection of integers. These are integers. Am I audible and clear?
Yes, ma'am.
Okay. No, because it's pouring cats and dogs here. I can only hear the sound of the rain outside my house. So, yeah. So these are the numbers. So I have to talk louder because the noise from the rain is so loud that I'm hardly able to hear myself.
Ma'am, we can hear you clearly, ma'am.
Okay, good. Yeah, children. So I was telling you that root 5 by root 7, though it may look like, or something upon something, some number upon some number, this is not an integer. This is not an integer. Integer by integer is a rational number. Integer by integer form is a rational number. Root 5 is not an integer. Root 7 is not an integer. So root 5 by root 7 is not a rational number. We have discussed all this earlier. Okay, now what kind of decimal expansion does this one have? Root 3. What kind of decimal expansion?
Ma'am, non-terminating, non-repeating.
Correct. Non-terminating, non-repeating. Non-terminating, non-repeating. Now to this, if I add 3, what kind of decimal expansion will the sum have?
Ma'am, non-terminating, non-repeating.
Yeah, because root 3 has a non-terminating, non-repeating decimal expansion. To that, if you add 3, the result also will be a non-terminating, non-repeating decimal. So what does it mean? This is irrational. This is rational. So if you add a rational number and an irrational number, the answer is irrational. The sum is irrational. You can just take examples to understand these. So you understood this example? Root 3 is irrational, 3 is rational. Non-terminating repeating decimal. This one is a non-terminating repeating decimal. Sorry, non-terminating, non-repeating decimal. To that, if you add 3, the result also will be a non-terminating, non-repeating decimal. So when root 3 is irrational, root 3 plus 3 or 3 plus root 3 is also irrational. All of you understand? Root 3 is irrational. 3, anything. So something like 5 plus root 3 is also irrational. Now again, root 7. Root 7 is irrational. 10 is rational. 10 is rational. Root 7 is irrational. This is non-terminating, non-repeating decimal. 10 minus this value, this non-terminating, non-repeating decimal, the difference will also be a non-terminating, non-repeating decimal. The difference of 10 and root 7. 10 is 10. It's a terminating decimal. But root 7, the value of root 7 is a non-terminating, non-repeating decimal. So you can just imagine the difference. You can just imagine the difference. So the difference also will be a non-terminating, non-repeating decimal. So 10 minus root 7 is irrational. We'll say 10 minus root 7 is irrational because this is irrational. This one has a non-terminating, non-repeating decimal expansion. So 10 minus this value will be another non-terminating, non-repeating value. So 10 minus root 7 is also irrational. See, 7 is rational. Root 11 is irrational. The product 7 into root 11, which is 7 root 11, is irrational. Root 11 is irrational. 7 is rational. Their product 7 root 11. Their product 7 root 11 meaning 7 into root 11 is 7 root 11. 7 root 11 is irrational because this is a non-terminating, non-repeating decimal. This one is a non-terminating, non-repeating decimal. This one multiplied by 7 will give you another non-terminating, non-repeating decimal. When you multiply this one, this value, this non-terminating, non-repeating value by 7, the result will be another non-terminating, non-repeating value, which is clearly irrational. So root 11 is irrational. 7 root 11 is also irrational, though 7 is rational. 7 is rational. Root 11 is irrational. 7 root 11 is irrational. So rational number plus irrational number is irrational. Rational number minus irrational number, irrational. I'll give you these notes later, children. You don't have to make a note of this. I'll show you this later. Rational into irrational is irrational. Again, the quotient also. Now, for example, root 7 by 2. Anything, you can write it the other way also. Irrational plus rational. You can also write it as, you can also write it the other way. You can also write irrational plus rational is irrational. Irrational minus rational is irrational. Irrational into rational is irrational. Irrational divided by rational is irrational. So whatever mathematical operation is performed with a rational and irrational, whatever mathematical operation, addition, subtraction, multiplication, division, whatever be performed with two numbers, one of which is rational and the other irrational, whatever be the mathematical operation, the result is always irrational. When you have a rational number and an irrational number, whether you add them, subtract them, multiply or divide, the result is irrational. The result is irrational. So now tell me, children, again, I'm just checking if you understood. So 3 is rational or irrational?
Rational number.
Rational number, ma'am.
Rational. What about root 13?
Irrational.
Irrational.
Irrational. What about the sum? Rational plus irrational. What about the
Irrational.
rational? It will be irrational. Root 5. Rational or irrational?
Irrational, ma'am.
2 root 5. 2 is
Irrational number.
2 is rational. 2 is rational. Root 5 is
Irrational.
rational. Product 2 root 5 is also irrational.
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 Yeah. Have we completed these, children?
Yes, ma'am. Yes, ma'am. Completed all the functions.
What is the one? All of you?
Yes, ma'am. Yes, ma'am.
All right. I think Prajit, your mic is enabled. Disable your mic.
Sorry, ma'am.
Okay. What is root 2 the whole cube? What's the value of root 2 the whole cube?
203. 202.
Root 8.
Ma'am, root 2 into root 2 into root 2.
Okay, the meaning is root 2 into root 2 into root 2.
The root 2,
Right?
ma'am.
What is root 2 into root 2? Root 2 into root 2 is 2. And 2 into root 2 is 2 root 2.
2 root.
Is it understood?
Yes, ma'am.
What is root 2 the whole square?
Root 2 into root 2, ma'am.
2.
2 into 2. What is root 2 into root 2?
2, ma'am.
2. How is it
2.
2? How is it 2? Because it is root of 2 into 2. Root of 2 into 2. So from 2 2s, 1 2 will come out. What is what's the answer?
Root 30, ma'am.
30, ma'am.
Root 30.
Root 30, ma'am.
Yeah, it's root of 2 into 3 into 5. It's root of 2 into 3 into 5. It's root 30.
Root 30.
Yeah. What is root 5 plus 2 root 5?
3 root 5.
3 root 5, ma'am. 3 root 5, ma'am.
3 root 5. Yes, 3 root 5. It's like x plus 2x, which is 3x. Correct. Now, I was telling you about like surds. Now tell me if these are like surds. What I'm writing? Are these like surds? Are these like surds?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
These are like surds. Surds are irrational numbers. Surds are irrational numbers. Expressions that are irrational are called surds. Expressions that are irrational are called surds. Now here 2 root 3. Root 3 minus 5 by 7 root 3 are like surds. The surd factor in it is root 3. That irrational factor is root 3.
Ma'am, can you repeat the definition of surds?
An expression which has an irrational value is called a surd. An expression which has an irrational value is called a surd. An expression which has an irrational value is a surd.
Yes, thank you, ma'am.
Yeah, so these are like surds because the irrational factor. Now, when you take the expression 2 root 3, when you take the expression 2 root 3, 2 is a rational factor. 2 is a rational factor. Root 3 is an irrational factor. When you take 2 root 3, 2 is a rational factor. Root 3 is an irrational factor. So, Tanya, your mic is enabled. Please disable your mic. Yeah, so when we look at this expression 2 root 3, 2 is a rational factor and root 3 is a irrational factor. What about the rational factor in root 3? What about the rational factor in root 3?
1, ma'am.
1 is the rational factor, 1. And what about the rational factor in this expression?
Minus 5 by 7.
Minus 5 by 7.
Minus 5 by 7 is the
Minus
rational
5 by
factor.
7, ma'am.
And the irrational factor is root 3. Okay, so the irrational factor everywhere is root 3, root 3, root 3. So these are like surds. These are like surds.
Ma'am, I have a doubt.
Yes.
Ma'am, if 2 root 3 is a surd, is the whole expression counted as a surd or only the root 3?
The surd is that if the one which has an irrational value. So in 2 root 3, this root 3, the entire thing also has an irrational value. But when we talk about the order of a surd and all that, we take only the irrational factor. Now, when you say 2 root 3, in this irrational factor to root 3, this irrational factor root 3 makes the whole thing a surd. And the order of the surd is determined by this root 3 alone, not the rational factor.
Okay, ma'am.
Now let's take some more examples. Now tell me if these are like surds. Are these like surds?
Yes, ma'am.
Yes, ma'am.
So can you add, subtract them?
Yes.
Yes, ma'am.
You can, like you can add and subtract like terms, you can add and subtract like surds.
Yes, ma'am.
Okay. Now, what is the order of this surd? What is the order of this surd?
4, ma'am.
So, order of this surd is 4. No, order is from here. 4th root of 20. So the order of this surd is 4. 4th root of 20. 4th root. The order of this surd is 4. What is the order of this surd?
2, ma'am.
2, ma'am.
2. 2 is the order of this surd. The order of this surd is 2. What is the order of this surd?
7.
7, ma'am.
7. Now, are these like surds? Are these like surds?
No, ma'am. They are unlike surds.
No, ma'am.
Like,
Are these like surds?
No, ma'am.
ma'am.
No, they're not like surds. They are not like surds. They are unlike surds. They are unlike surds of different orders. The order here is 3. The order here is 2. What about these? Are they like surds or unlike surds? Root 5 and root 7.
Like surds, ma'am.
Unlike surds, ma'am.
Unlike.
Root 5 and
Unlike
root 7.
surds, ma'am.
Supposing we had 2 root 5 and 7 root 7. Can you add or subtract these two?
No, ma'am.
No, you cannot.
Ma'am.
5 and 7 root 7 cannot be simplified further. You can multiply them. You can divide. You cannot simplify further on division, but the operation multiplication and division can be performed, but you cannot add or subtract. These are unlike surds. Of the same order, the order is 2. The order of the surd is 2. The order is 2. They're unlike surds of the same order 2. See, this order is 2. They're unlike surds of the same order 2. So you should be able to differentiate between like surds, unlike surds. If they're like surds, they will have the same order. When you call some expressions like surds, they will have the same order. When you have some expressions and you look at all of them and you say, yeah, these are like surds, that means they will have the same order also. So in like surds, we don't have same order, different order, only like surds. In unlike surds, we have unlike surds of same order, unlike surds of different order, unlike surds of different order. Like for example, root 2 and root 3 are unlike surds, but of the same order 2. Root 2 and root 3 are unlike surds, but of the same order 2. Now, if we write cube root of, whatever 3 and some 5th root of 7, they are unlike surds, but of different order 3 and 5. But of different order 3 and 5. Cube root of 3 and 5th root of 7 are unlike surds of different order. The order in one expression is 3, the other one is 5. Now, these are not important from your examination point of view. This is just for your information. Like surds will have the same order. There is no question of different order. Like surds. Unlike surds are of two types. Same order, different order. On like surds, you can add, subtract, multiply, divide. You can perform all the 4 mathematical operations on like surds. Like terms can be added, like surds can be added, subtracted, multiplied or divided. Unlike surds, you cannot perform addition and subtraction. You can multiply or divide. Similar to algebra, like terms, unlike terms. What can you do with like terms? What can you do with unlike terms? Like terms, you can perform all the 4 mathematical operations. You can add and subtract. Most importantly, like terms can be added and subtracted. Same thing here, like surds, you can add, subtract, and of course you can multiply and divide. Unlike surds, you cannot add or subtract them. Meaning they cannot be simplified further. The same expression will be the answer. You can multiply or divide them. All right. So now, what you see on your screen is the introduction to the concept rationalization. So to understand rationalization, we had to understand how to evaluate expressions. What you did in the last class. Evaluating expressions using algebraic identities. End of last class, we understood how to evaluate expressions using algebraic identities. That forms an integral part of rationalization. You need to, let me go back to that file, 1 second. Yeah, this one. This is very important. So how do we multiply these two using the identity a minus b the whole square? Children, any doubts here? Because if you carry forward your doubts regarding this one, then rationalization will look difficult. Let me just double check. Let me make sure. So what you see here is in the two brackets, you have the same terms. You have the same terms 4 root 5 and 3 root 2 separated by a plus sign here, a minus sign here. So this is of the form a plus b into a minus b. This is of the form a plus b into a minus b, which can be simplified using the expression a square minus b square. Because we know that a plus b into a minus b is a square minus b square. So that's what you need to first identify, how they look like, how the expression looks like. The expression is of the form a plus b into a minus b. So the result is a squared minus b squared. Your a is 4 root 5. Your b is 3 root 2. So see here, first you should write the identity and then you should pick out the value of a and b. You must pick out the value of a and b. And then this is the expression to be evaluated. This one. This is what you have to evaluate. You have to find the value of this expression. So that's nothing but because this is a plus b into a minus b. The answer is a square minus b square. What is a? 4 root 5. A square. So 4 root 5 the whole square. Minus, from where did we get the minus sign? From here, this minus. You should pick all the signs from the identity. You must pick the signs from the identity. And b square. What is b? B is 3 root 2. So b square, 3 root 2 the whole square. So this is what you see here, a square minus b square. Now how do you simplify this? 4 root 5 the whole square means 4 root 5 into 4 root 5. 4 into 4 is 16. Root 5 into root 5 is root of 5 into 5. You don't have to show these steps. You can directly write the answer. I'm just telling you. So 4 into 4, I'll come from the beginning. So when it is 4 root 5 the whole square, it means it's 4 root 5 into 4 root 5. 4 root 5 the whole square is equal to 4 root 5 into 4 root 5. So how do we multiply? 4 into 4, 16. Root 5 into root 5 is root of 5 into 5. Root of 5 into 5. So from 2 5s, 1 5 will come out. So 16 into 5. So remember, root 2 into root 2 is 2. Root 3 into root 3, 3. Root 4 into root 4, 4. Root 5 into root 5, 5. Root 6 into root 6, 6. You don't have to every time work this. Why? Because why is root 3 into root 3, 3? Because it will be root of 3 into 3. And from 2 3s, 1 3 comes out of the square root. So root 3 into root 3 is 3. So 4 square is 16. Root 5 the whole square is 5. 3 square is 9. Root 2 the whole square is 2. 16 5s are 80. 9 2s are 18. 80 minus 18 is 62. So the value of this expression is 62. So when you find expressions of this form, so it's clearly this expression is irrational, children. This expression is irrational because here it's a product 4 root 5. 4 root 5 is a product of an of a rational and irrational value. Root 5 is irrational. 4 is rational. Rational into irrational is irrational. And this one, root 3 is rational. Root 2 is irrational. So the product will be irrational. And this irrational value plus this irrational value will be another irrational value. See, to understand if an expression is rational or irrational, you should analyze every part of the expression. Once you start working, looking at it, you can directly say you don't have to analyze every part of the expression every time. Now, since we're just getting started, this is rational. 4 is rational. Root 5 is irrational. The product is irrational. 3 is rational. Root 2 is irrational. The product is irrational. Irrational plus irrational is another irrational value. All right. So this is an irrational value. This is another irrational value. You can see that the product of these two irrationals is rational. This is irrational. This one is irrational. This one is irrational. And you can see that the product of these two irrationals is rational. That we already know. See, root 2 is irrational. Again, root 2 is irrational. Their product is rational. So whenever you have to, answer a statement like, is the product of a rational and irrational, rational or irrational, take examples. Take examples and come to a conclusion. Take examples and come to a conclusion. See, I'm saying root 2 is irrational. It's irrational. These two are irrational, irrational, irrational. That product is rational too. This entire thing is irrational. This entire thing is irrational. Their product you see is 62, which is rational. Okay. So I told you how to evaluate 4 root 5 the whole square. Say 3 root 2 the whole square. So again, very important. Let me just do this alone and we'll get started with rationalization. So here also the identities a minus b the whole, a minus b the whole square, a minus b the whole square, which is a square minus 2ab plus b square, a square minus 2ab plus b square, where a is 6 root 2 and b is 2 root 6. A is 6 root 2, b is 2 root 6. Now what's the answer? What is a minus b the whole square? A square, 6 root 2 the whole square, minus 2ab. That's the identity. Minus 2ab minus 2 into this is a, this is b. 2 into a into b plus b square plus b square. So we're getting the signs from the identity. We're getting all the signs from the identity. A minus b the whole square should be handled like this. handle like this. A square minus 2ab plus b square. A square, what's the value of a? 6 root 2. A square, 6 root 2 the whole square. B square, 2 root 6 the whole square. 2ab, 2 into a into b is what you see here. Signs minus 2ab, so minus 2ab plus b square, so plus b square. Now how to simplify? So 6 into 6, 36. Root 2 into root 2 is 2. 2 6 are 12. 12 2s are 24. Root 2 into root 6 is root of 2 into 6. 2 square is 4. Root 6 the whole square is 6. All of you please look at your screen. When you square this one, 6 root 2 into 6 root 2. 6 into 6, 36. Root 2 into root 2, 2. So 36 into 2, next step 72. This one, 2 root 6 the whole square is 2 root 6 into 2 root 6. You can multiply anything. So 2 into 2, 4. Root 6 into root 6, 6. 4 6 are 24. Next step. So these two numbers we understood how we got them. These two we understood. Now the middle term, 2ab. 2 6 are 12. 12 2s are 24. 24. Root of 2 into 6. Root of 2 into 6. Now 6 should be factorized. 6 can be written as 2 into 3. 6 can be written as 2 into 3. See here, this 2 as it is. The 6 is 2 into 3. So now from 2 2s, 1 2 will come out. From 2 2s, 1 2 comes out. From 2 2s, see the 6 is written as 2 into 3. And now from 2 2s, 1 2 comes out. So you have this 24. From these 2 2s, 1 2 comes out and root 3 under the square root. I'm sorry, 3 under the square root. 3 under the square root. This 24 from these 2 2s, 1 2 out of the square root. And this 3 remains under the square root. Plus 24 and this one. So now 24 into 2 is 48. 48 root 3. And 72 plus 24. 72 plus 24 is 96. So 96 minus 48 root 3 is the value of this expression. 96 minus 48 root 3. Now tell me, is the answer rational or is the answer rational or irrational?
It's two terms, a rational number and an irrational number.
No, is this entire expression rational or irrational?
Ma'am, it's irrational.
Irrational, ma'am. Irrational.
Irrational, ma'am.
Rational.
Yeah, 96 is rational. But yeah, the entire expression is irrational. The
Yes,
entire expression is irrational. Children, now please tell me, are you sure you understood this? How to simplify?
yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So when we, take up this concept rationalization, we will be frequently using these identities: a plus b the whole square, a minus b the whole square, and a square minus b square. So you can take a screenshot of this one and write it later. Leave some space and complete it later. I'll just tell you what is in this slide. So what is rationalization? When the denominator of an expression is irrational. When the denominator of an expression is irrational, the procedure or the process you adopt To convert that irrational denominator to a rational denominator is called rationalization. I repeat, you have an expression. The denominator of the expression is irrational. You want to have the expression with a rational denominator. Like you always want to start with a positive note, you don't want to, when you step out to school, you don't want to fight with somebody at home, or, you want to step out of your house with a pleasant note. You don't want to argue with somebody and then step out. We always believe in positivity. Yeah, so you can just take it like that. So when the denominator is irrational, you're not happy with an irrational denominator. You want a rational denominator. So the process of converting the irrational denominator to a rational denominator is called rationalization. So how to convert? That's what we are going to see next. That process adopted to convert the irrational denominator to a rational denominator is rationalization. Now, the thing is, now supposing 1 by root 2, okay? 1 by root 2. Now, when I rationalize this, you will not understand now. So I'm rationalizing. Yeah, now this is the answer. This is the answer. Now, 1 by root 2, see, okay, let me do it again. So 1 by root 2, the given expression is 1 by root 2. The denominator is irrational. I don't want an irrational denominator. I want a rational denominator. So this is the procedure. This is the procedure. What we do, we multiply the numerator and denominator by root 2. Now I get 1 into root 2 is root 2 and root 2 into root 2 is 2. Now you can see that, haven't we learned the concept of equivalent fractions in as early as in 4th to 5th standard? So when the teacher gives you a fraction 4 by 5, you multiply and divide by 2. And you say the teacher 8 by 10 is a fraction equivalent to 4 by 5. Then you also give her, you can give her so many answers. Then next you work this and you tell her 12 by 15. 12 by 15 is another fraction equivalent to 4 by 5. So when you're multiplying and dividing by 2, you're only multiplying by 1. You're only multiplying by 1. See, so 2 by 2 means 1. 3 by 3 means you're multiplying by 1. So into root 2 by root 2, you're just multiplying by 1. Root 2 by root 2 is 1. It's just 1. So you're not changing. You're not changing the value of the given expression because you're only multiplying the expression by 1. If you add 0 to something, you're not changing its value. You add 0. You have something. You add 0 to it. You will not change its value. Similarly, when you multiply an expression by 1, you're not changing its value. You're just going to see it in a different form, but it has the same value. Let me come from here. So this you can recall, right? All of you, by 5, which is 10 by 35. So 10 by 35 is a fraction equivalent to 2 by 7. This we can recall, right? So can we say that 2 by 7 is equal to 10 by 35? Can we say that 2 by 7 is equal to 10 by 35?
Yes, ma'am.
Yeah, we
5
can.
into 5 by 5 is 10 by 35.
Yeah, okay. What is it? 5 by 5, 1. So what are you doing actually? You're multiplying 2 by 7 by 1. So you're not changing its value. It becomes 10 by 35, but its value is the same as 2 by 7. So you would have understood this when you were young. So it's like, you have a cake and you make 7 equal portions and you take 2 out of it. You have a cake, you cut it into 7 equal portions and you take 2 pieces out of it. It's the same as cutting the same cake into 35 equal pieces and taking 10 pieces out of it. This 10 piece, all these 10 pieces put together will make, the size of these 2 pieces, 10 by 35 may look different from 2 by 7, but the value is the same.
Yes, ma'am.
Okay, so when you have 1 by say root 3. So what we do, the denominator is irrational. You don't want to have an irrational denominator. You want to rationalize it, meaning you want to have a rational denominator. So you can multiply the numerator and denominator by root 3. What happens? 1 into root 3 is root 3. 1 into root 3 is root 3. Root 3 into root 3 is 3. So now see what happens to the denominator. It becomes rational. The denominator is rational. The denominator is rational. But the expression 1 by root 3, this expression is irrational. And so is root 3 by 3. The expression is still irrational. You cannot make an irrational expression rational. How is it possible? That means you're changing its value. How can an irrational value become rational? So you are not only the denominator which was irrational becomes rational, but the expression see here root 3 by 3 is still irrational. The expression is still irrational. Just that irrational part has gone to the numerator. Am I clear, children? When you rationalize the denominator, that is when you make the irrational denominator rational, the denominator becomes rational, but the expression which is irrational remains irrational. The expression cannot become rational.
Ma'am?
Yeah.
Ma'am, can we follow the same procedure of the numbers 2 by root 3?
Yes,
2 or any
same.
other number?
Yeah. Same procedure.
Okay, ma'am.
Yeah. Yes, children, give the heading. Rationalize the denominator. Take a screenshot. Yeah, I didn't tell you about this. So that's what is rationalization. I just explained what is rationalization. Now we'll understand rationalizing factors. Now, when you have a denominator like this, 3 minus root 2. 3 minus root 2. How many videos are on? Sanjay and Prajit. Good.
Ma'am, I have no charge, so I can't on my video, ma'am.
Children, excuses are many, children. To be in this classroom, kindly see to that your video is as important as your mic. Yes or no? Will you not fix your mic issues? In the same way, we'll not have excuses for, video and audio.
Ma'am, I have no charge, so I can't on my video, ma'am.
Who's that? Netra, is
Ma'am,
it?
Netra. Yes, ma'am.
Okay.
Okay, ma'am.
Jayant, you have logged in from 2 different devices, Jayant.
No, ma'am.
Leave from one device. And turn on your video. All right. So now when we have an expression like 1 by, we'll work all this, children. Just listen now. When we have an expression like 1 by 3 minus root 2, the rationalizing factor, now when it was 1 by root 2, we multiplied the numerator and denominator by root 2 to rationalize the denominator. Now, when you have this expression 1 by 3 minus root 2, 1 by 3 minus root 2, you have to multiply the numerator and denominator by an expression 3 plus root 2. See, understand that when you multiply and divide by the same expression, you're multiplying by 1. Okay. Now, what happens when it is in the form a minus root b? Can you see it? A minus root b. It's in the form a minus root b. A minus root b. Then its rationalizing factor will be a plus root b. will be a plus root b. When the denominator is of the form a minus root b, its rationalizing factor will be a plus root b. Or if the denominator is like this, if the denominator is of the form a plus root b, then you will have to multiply and divide by a minus root b. A minus root b. So we say that a plus root b is the conjugate of a minus root b, and conversely a minus root b is the conjugate of a plus root b. That is, when you multiply two irrational expressions and the answer is rational, then one is said to be the conjugate of the other. When you multiply, we'll see that when we multiply 3 minus root 2 and 3 plus root 2, in the answers I'll show you that when we work some problems, you will see that you will get a rational answer. The product is rational. So when you multiply, when the product of two irrational expressions is rational, then one expression is said to be the conjugate of the other expression. Now, I normally don't, explain too much of theory like this, children. When we work the sums, I'll relate that to this and you will understand. I'll relate that to this and you will understand. So for now, we have understood what rationalization means. Making an irrational denominator rational is rationalization. Making an irrational denominator rational is rationalization. The expression will still remain irrational. And then I need to explain more about conjugates. What is meant by a conjugate? I'll tell you. Just take a screenshot of the slide. Yeah, and leave some space. Complete this in your book later. Now, give this heading, start working this. So in the expression 2 by root 5, in the expression 2 by root 5, the denominator root 5 is irrational. To rationalize the denominator, we need to multiply the numerator and denominator by root 5, which is multiply the numerators to root 5, multiply the denominators. Root 5 into root 5 is 5. Now you can see that the denominator is rational. All of you must tell me if you understood the first one. You don't have to put all this, children. I'm just showing you that you're multiplying the numerators and denominators.
Understood, ma'am.
Yes, ma'am.
Yeah.
Understood.
Understood, ma'am.
Understood, ma'am.
Okay. So what is the given expression?
Two by root
What is
5.
it?
2 by root 5, ma'am.
2 by root 5. The given expression is 2 by root 5. In 2 by root 5, what about the what do you say about the numerator? Is it rational or irrational?
The numerator is rational, ma'am.
The numerator is rational. What about the denominator?
It's irrational, ma'am.
Irrational.
It's irrational. So what do we what is our what do we need to do? We need to rationalize. That is, make the denominator rational. Yeah. So for that we multiply and divide by root 5. How do you multiply? Multiply the numerators. 2 into root 5 is 2 root 5. See, you can multiply anything. You don't have to check if they're like terms or unlike terms. Anything. 2 into root 5, 2 root 5. By its multiplication. Root 5 into root 5 is 5. Now you can see the denominator is rational. The numerator is irrational now. That means the expression is still irrational. It's just that the denominator has become rational now. See the second one. make a note of this, children. Somewhere you write it in a cloud. Just put it in a cloud. Pure surds, mixed surds. Okay, I'll tell you what. So now root 5 is a pure surd. Root 5 is a pure surd. Root 24 is a mixed surd. Root 24 is a mixed surd. Why? This is the reason. 24, listen to me fully. Then you just make a note of it in whichever way you want. Let us take 24. The terms are pure surd and mixed surd. Like we say proper fraction, improper fraction. I'm just relating it to something of your junior standard so that you know it's easy to catch. So don't we say proper fraction, improper fraction? So like that, or mixed fractions. So like that, pure surds, mixed surds. Now 24. Take up 24.
Spell it, Mum's words.
Yes, Devadarshini.
Mum, can you spell that word pure?
Pure surds. Okay. Pure surds. Mixed surds. Mixed surds. Now 24 is a mixed surd because 2 12s, 2 6s, 2 3s, 3 1s. So children, I have not still answered question number 2. Just listen to this. I'll tell you what to write. Now 24 is equal to, that is square root of 24 is equal to square root of 2 into 2 into 2 into 3. So now from these two 2's, 1 2 will come out. So square root of 24 is 2 root 6. Do we all understand that? Take your time.
Yes, ma'am.
Now
Yes,
you'll ask me why you didn't do that for root 5. Root 5, nothing. What will you do with root 5? The first one. The first one, root 5. You will only start 5, then 5 1s are 5. That's all. So there is no point. When you try to express 5 as a product of its prime factors, you will get 5 only. So not every surd can be expressed as a mixed surd. Every surd cannot be expressed as a mixed surd. So it depends on the factors the surd has. Root 5 is root 5. It's a pure surd. Because its rational factor is 1. Because its rational factor is 1. 1 root 5. No, root 5 means 1 root 5. Because its rational factor is 1. Now 2 root 6 is a mixed surd. 2 root 6 is a mixed surd. The rational factor is 2. It's not 1. So if the rational factor is something other than 1, 1 or minus 1. If the rational factor is something other than 1, 1 means 1 or minus 1. Then it's a mixed surd. These terms are just for your knowledge. Nobody will ask you what a pure and mixed surd is. Because I will be using these terms when I teach. So you should know what they mean. So children, 24, when you find the prime factors of, when you work the prime factorization of 24, you get 2 into 2 into 2 into 3. See, it's square root of 24. It is not only 24, it's square root of 24. So square root of 24 is equal to square root of 2 into 2 into 2 into 3. Now from 2 2's 1 2 comes out. So now this 2 3's are 6. So root 24 can be expressed as 2 root 6. So square root of 24 can be expressed as a mixed surd. It's a mixed surd because its rational factor is not 1 or minus 1, it's 2. So it's a mixed surd. So that is the first step. Before you rationalize, you must check if you can simplify further. If you can express the denominator. See children, in front of your video, please take a good poster. It's very distracting otherwise. To whomsoever it may concern. Take a good posture. If you need to disturb yourself for some time, turn off your video and quickly turn on after you finish the task. Yes, children. So simplification is important. If possible, simplify. If possible, simplify and then do the rationalization. Now, in this 3 by root 24, the next step, this is the question. So you start your solution like this. So 3 by root 24 is equal to 3 by root of 2 into 2 into 2 into 3. So from 2 to 1 2 comes out. So that's equal to 3 by 2 root 6. You can directly write 3 by 2 root 6. Now, because you're just starting, you have to show this step. Otherwise, you can directly write 3 by 2 root 6. All right, children. So now in 3 by 2 root 6, what is irrational? In 3 by 2 root 6, what is irrational? Is 2 irrational? No, is 2 irrational? Only root 6 is irrational. Correct. Only root 6 is irrational. So 3 by 2 root 6, multiply and divide only by root 6. Children, you keep writing one below the other. I'm just writing it in the side because I have place here. You keep writing one below the other. So though it is 2 root 6, 2 is rational. 2 is rational. Root 6 is irrational. See, when it is 2 root 6, it's 2 into root 6. It's 2 into root 6. So you can separate them. It's 2 into root 6. 2 and root 6 are separable. If it was 2 plus root 6 or 2 minus root 6, they are not separable. When they are connected by a plus or a minus sign, 2 plus root 6, 2 minus root 6, they are not separable. You cannot separate them. 2 plus root 6 is one term. Sorry, one expression. 2 minus root 6 is one expression. You cannot separate. You cannot look at it separately. But 2 into root 6, 2 into root 6, 2 and root 6 are separable. So the rational factor is 2. Leave it. Irrational is 6. So multiply and divide only by root 6. So you will get 3 root 6 divided by what is you need to multiply 2 root 6 and 6. What is root 6 into root 6? 6. And what is 6 twos are? 12. Is it understood? Root 6 into root 6 is 6 and 6 twos are 12. Now this can be simplified further. 3 ones are 3 fours are. So root 6 by 4. Now you can see the denominator has become rational. Please write down this one. Sindhu and Sanjay, disable your mic. Children, do you get the difference with the first and second one? In the first one, you directly multiply and divide by root 5. In the second one, so every time you have to check if the prime factors will have equal primes, like 2 twos or 4 twos or 6 twos or 2 threes, 2 fives. You must always check the denominator if it can be expressed as a mixed surd. Not always you can write it as a mixed surd. Sometimes you can, sometimes you cannot. Root 5 cannot be expressed as a mixed surd, but root 24 is 2 root 6. You must first do that and then rationalize. To rationalize, it's enough if you multiply and divide by root 6. So now they'll give you this expression 3 by root 24. They'll give you this expression and the question will be, what is the rationalizing factor of 3 by root 24? What is the rationalizing factor of 3 by root 24? And they'll give you 4 options and you will select root 24, which is wrong. The rationalizing factor of 3 by root 24. That is, the question is by what will you multiply and divide? That's what they're asking you. What will you multiply and divide to make 3 by root 24? To rationalize the denominator of 3 by root 24. What is the least rationalizing factor? Okay, I forgot the word least. What is the least rationalizing factor? The smallest rationalizing factor. Like we say, the least common multiple. Now for 6 and 12, the least common multiple is 12. But 24 is also a common multiple. If you take 24 also, you will get the answer, same answer. You can take any common denominator, but the least common denominator is 12. So for 6 and 12, if they ask you what is the LCM of 6 and 12, and you write 24. 24 is a common, it is a common multiple. That's not the least common multiple. So your answer is wrong. Yes or no? What is the LCM of 6 and 12?
12, ma'am.
12. If you write 24, will you expect your teacher to give you marks for that? No, because it's a common multiple of 6 and 12, but it's not the least common multiple of 6 and 12. Like that, the smallest or the least rationalizing factor is different from a rationalizing factor. So if you write the rationalizing factor as root 24, you will get marks, but the least rationalizing factor, the smallest, is root 6. Because you are no, not here, sorry, this one is root 6. Because you're multiplying, dividing by root 6, not root 24. Because you multiplied, and see, you multiply the numerator and denominator. Because you multiply the numerator and denominator by root 6. By root 6, you did not multiply and divide by root 24. The smallest rationalizing factor is root 6. Do we understand that, children?
Yes, ma'am. Yes, ma'am.
Okay. So in the first one, you directly multiply and divide by root 5. In the second one, you will have to express root 24 as a mixed surd. You will have to express root 24 as a mixed surd. 2 root 6. Then proceed with the rationalization. It is enough if you multiply and divide by root 6 because 2 is already rational. The same heading, under the same heading, children. Yeah, try this. Eight by root 125.
Ma'am, I got the answer.
Yeah. What is the, how do you express root 125 as a mixed surd?
5 root 5, ma'am.
5 root 5. Very good. So 8 by root 125 is equal to 8 by root of 5 into 5 into 5. Correct. Because 125, 5, how many times?
3 times, ma'am.
3 times.
25 times, ma'am.
20
5
times.
25 times. 5 fives are. 5 ones are.
5 ones are.
Correct. So from 2 fives, 1 5 comes out. And this 5 remains under the square root. So root 125 can be written as 5 root 5. Can be written as 5 root 5. I've shown the steps here. Now in 5 root 5, 5 is rational. 5 is rational. Root 5 is irrational. Root 5 is irrational. You can separate it. In 5 root 5, you can separate 5 and root 5. In 5 plus root 5, you cannot separate them. 5 plus root 5 is one expression. 5 minus root 5 is one expression. But in 5 into root 5, you can look at 5 and root 5 separately. So 8 by 5 root 5. So Madhumita, what did you multiply and divide with?
Root 5, ma'am.
Root 5 alone, just root 5. So the numerator is 8 into root 5, which is 8 root 5 divided by root 5 into root 5 is
25, ma'am.
yeah, root 5 is 5. 5 5s are 25. And supposing 8 and 25 you can cancel, simplify, you can do it. But now it's not possible. Here it's not possible. 8 and 25 cannot be simplified. So this is the result. And you can look at the denominator 25 is rational. So first convert the surd which is given in the denominator to a mixed surd. It's possible. So convert that to a mixed surd. And then rationalize. To rationalize, we use only root 5. So the least rationalizing factor or the smallest rationalizing factor is root 5, not root 125, root 5. Yeah, all of you, please write on your books.
Completed, ma'am.
Completed.
Very good. All right. So far, we have just understood very simple ones, how to rationalize the denominator of how to rationalize the denominator of very simple expressions. So what you've learned so far is, if the denominator cannot be expressed as a mixed surd, then you can directly multiply and divide with whatever you see in the denominator, like root 2 means into root 2 by root 2. But if the denominator can be expressed as a mixed surd, you should first do that and then proceed with the rationalization. All right, the next heading, rationalize the denominator. Write it again. Write the heading again, children. Rationalize the denominator. See how we do the first one. Please watch. 1 by 3 plus root 2. This is the given expression. Clearly, the denominator is irrational. And the heading is to rationalize the denominator. That is, make the denominator rational. Now we make use of the conjugate. The conjugate of 3 plus root 2 is 3 minus root 2. Just change the sign. In 3 plus root 2, 3 and root 2, they are not separable. You cannot separate them. You cannot say 3 is rational, root 2 is irrational. No. When in the expression, the terms are connected by a plus or minus sign, you must look at them as a whole. A plus B is one expression. A minus B is one expression. A, B. You can look at A and B separately. A into B, A separate B. Okay, what do I mean by that? Fine, let me, 1 minute, I'll tell you what I mean by that. Now, supposing we have 8 into 5 children. Can't we cancel? 4 ones are 4 twos are? All of you nod or say yes. Yeah. When we have 4 by 8 into 5, can I cancel 4 ones are and 4 twos are like this? Yes or no?
Yes, ma'am.
Why? Because 8 and 5, they are not 8 and 5, they are separable. 8 into 5, 8 and 5 are separable. But if I have 4 by 8 plus 5, just to make you understand, if I have 4 by 8 plus 5, can I cancel 4 ones or 4 twos are?
No, ma'am.
No, I have to add 8 plus 6 what? 8 plus 5 is 13. Now I can cancel. That means 8 and 5, they're not separable. You have to add first. That's what I meant by saying they're not separable. Supposing you had 4 by 16 minus, whatever, 5. You cannot cancel 4 and 16. 4 by 16 minus 5 means 4 by 16 minus 5 is 11. Now you can cancel 4 and 11 if possible, but it's not possible. That's what I mean by saying they're not separable. 1 by, okay, so 7 by 14 into 3. You can cancel because 14 is separate, 3 is separate. 7 ones are 7 twos are. 3 is not bothered. 14 is becoming 2. 3 is not bothered. Let it become whatever it wants. But if you have 7 by 14 plus 3 or you have a minus 3, you cannot cancel. They make like they're close friends. They make one bond. You cannot separate them. 14 plus 3 or 14 minus 3. You cannot separate them. They will merge into 14 plus 3, 17 or 14 minus 3, 11. Now you can simplify. Okay. So when it's addition or subtraction, when the terms are connected by a plus or minus sign, they are not separable. They make one expression. But if it is multiplication, you can look at them separately. So now the first one, 3 plus root 2 is one expression, 3 plus root 2. Don't say 3 is rational, root 2 is irrational. So why you want to take 3? No, 3 plus root 2 is, they come together. So the rationalizing factor. Yeah. So the rationalizing factor. Now, of course, children, am I audible and clear?
Yes, ma'am.
Yeah. So in the expression, okay. So in 3 plus root 2, 3 is rational. 3 is rational. Root 2 is irrational. That's fine. But 3 plus root 2, they are not separable. They are rational. The rationalizing factor or the conjugate of 3 plus root 2 is 3 minus root 2. So you should multiply and divide by 3 minus root 2. I wrote it in the question itself. Let me write the question and the answer. So this is the question. 1 by 3 plus root 2 is the question. You must start your solution like this. Write the given expression and multiply. Multiply and divide by 3 minus root 2. Next step, multiply the numerators. So it will be 3 minus root 2 by multiply the denominators. 3 plus root 2 into 3 minus root 2. Now in the numerator, nothing possible. Write it as it is, divided by what identity in the denominator? How is it like? A plus B into A minus B.
B square, ma'am.
A square minus B square. So 3 square minus root 2 the whole square. A square. A is 3. B is root 2. A square minus B square. So 3 square minus root 2 the whole square. So write the numerator as it is, divided by 3 square is 9 minus root 2 square is 2. Now you should have got used to it. 3 minus root 2 by 7. Now you can see the denominator is 7, which is rational. So we say that the conjugate of 3 plus root 2 is 3 minus root 2. And the conjugate of 3 minus root 2 is 3 plus root 2. Because when you multiply them, they give a rational answer. See, in the denominator, you had 3 plus root 2 and 3 minus root 2. When you multiply them, you got 7. You're getting a rational answer. That is why one is the conjugate of the other. Are Arjun will teach us the next one. Arjun, get ready with the second one. Children, is it understood, the first one?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
All right, children. So the conjugate of 3 plus root 2 is 3 minus root 2. The conjugate of 3 minus root 2 is 3 plus root 2. Because when you multiply them, because their product is rational, 7. Their product is rational, 7. Yes, Arjun?
Ma'am, 1 minute, ma'am, solving.
No. We'll do it together. 8 plus 5 root 2. Yes.
And I completed the sum.
Okay, please wait. Thank you. Yes, children? Arjun, yes, what's the conjugate of 8 plus 5 root 2? Who can tell us the, who can tell me the conjugate of 8 plus 5 root 2?
Ma'am, can I?
Ma'am, shall I? And 8 minus 5 root 2. 8 minus 5 to the root 2, ma'am.
Yes, others?
8 minus
8
5.
minus 5 root 2 by 8 plus 5 root 2 into 8 minus 5 root 2.
Correct. 8 minus 5 root 2. Just change the sign. 8 minus 5 root 2. So 8 multiply the numerator and denominator by 8 minus 5 root 2. Now what will be the next step? Multiply the numerators. 1 into, you should multiply the numerators. 1 into anything is the same thing. So 8 minus 5 root 2 will come as it is, divided by the denominators. Okay. 8 plus 5. Yeah, I should multiply them. So write it like this first. Write it like this first. Next step here. So write the numerator as it is, nothing can be done there. In the denominator, it's of the form a plus b into a minus b, which is a square, 8 square minus b square, 5 root 2 the whole square. Numerator as it is, what is 8 square?
64.
Yeah, what is 5 root 2 the whole square?
25 into 2,
24.
ma'am.
25 into 2, ma'am.
25 into 2, ma'am. Which is 50, ma'am.
This is 50. So write, you can write 50 straight away. You can write 50 straight away. You can work, you can do that in your rough column 5 root 2 into 5 root 2. You can work it there and put the answer straight away. So 8 minus 5 root 2 divided by what is 64 minus 50?
14, ma'am.
14, ma'am.
Now see, the denominator has become rational. The denominator is rational. The numerator is irrational. The whole expression is still irrational. The irrational expression will remain irrational. Just that the irrationality will shift from the denominator to the numerator. Got it, children?
Yes, ma'am.
Okay, so the rest of it is homework. Complete this. I need to change the slide. Please write one below the other, children. One below the other. Done, children?
Yes.
Completed, ma'am.
All right. Now take a screenshot. You can also see the answers there. But don't copy. You can try first, or you can go through the slide and then Meaning you can go through your screenshot and then work. The choice is yours, but understand what you're working. And remind me, we need to discuss these answers in the next class. Remind me about that. When we begin the class, we need to discuss the answers to 3, 4, and 5.
Yes, ma'am.
I'll be sending you some more homework, children. Maybe on Monday. I'll try to make it by tomorrow. If not by Monday, I'll send you some homework completed by the next class on Tuesday.
Yes, ma'am.
All of you took a screenshot?
Yes, ma'am.
Yes, ma'am.
Yeah, see, children are switching between the two modes, you know. You're turning on your video when I try to look at the videos. When I'm on my screen, you're turning off your video. No, the one thing I can tell you is you don't know. I myself don't know my temper. Because when I give you an instruction and children don't follow it, then I take my decision. I don't do anything abruptly. I definitely don't show my mood on anybody. I always try to be good with children. But if instructions are given and not followed, then you should be ready to face the consequences. So what can be the consequence? I'll remove you from the meeting. Please keep your videos turned on throughout the meeting. If you have any issues with the camera, rarely, every other day, you cannot say that. Kindly text me. We'll not talk this in the meeting. Text me. Your videos must be on all through the meeting. Not only when I check to see if you're all there. All right, children, I hope the class was useful. All of you understood? Any questions, children?
No.
No? All right. Fine, children. That's it
Thank
for today's session. Thank you so much. Good night.
Thank you, ma'am.
Thank you, ma'am.
you, ma'am.
Thank you. Night.